In particle physics, a rho meson is a short-lived hadronic particle that is an isospin triplet whose three states are denoted as rho plus, rho 0 and rho minus. After the pions and kaons, the rho mesons are the lightest strongly interacting particle with a mass of roughly 6990123367589499000 770 MeV for all three states. There should be a small mass difference between the rho plus and the rho 0 that can be attributed to the electromagnetic self-energy of the particle as well as a small effect due to isospin breaking arising from the light quark masses. However, the current experimental limit is that this mass difference is less than 6987112152354090000 0.7 MeV. The rho mesons have a very short lifetime and the decay width is about 698923215590615000145 MeV, with the peculiar feature that the decay widths are not described by a bright Wiener form. The principal decay route of the rho mesons is to a pair of pions with a branching rate of 99.9%. Neutral rho mesons can decay to a pair of electrons or muons, which occurs with a branching ratio of 699550000000000000000000000000000000000000000000000000000000000000000000000000000000000 times 10⁻⁵. This decay of the neutral rote leptons can be interpreted as a mixing between the photon and rho. In principle, the charged rho mesons mix with the weak vector bosons and can lead to decay to an electron or muon plus a neutrino. However, this has never been observed. In the de Ruggiero-Georgi-Glashow description of hadrons, the rho mesons can be interpreted as a bound state of a quark in an anti-quark in as an excited version of the pion. Unlike the pion, the rho meson has spin J equals 1 and a much higher value of the mass. This mass difference between the pions and rho mesons is attributed to a large hyperfine interaction between the quark and anti-quark. The main objection with the de Ruggiero-Georgi-Glashow description is that it attributes the lightness of the pioneers as an accident rather than a result of chiral symmetry breaking. The rho mesons can be thought of as the gauge bosons of a spontaneously broken gauge symmetry whose local character is emergent. Note that this broken gauge symmetry is distinct from the global chiral symmetry acting on the flavors. This was described by Howard Georgi in a paper titled The Vector Limit of Chiral Symmetry, where he ascribed much of the literature of hidden local symmetry to a nonlinear sigma model. A PDG reports the resonance width. Here the conversion tau equals h. Gamma is given instead. The exact value depends on the method used. See the given reference for detail.